Welcome to the course Network Analysis. Today we will discuss the superposition theorem. Requirements of superposition theorem. So first is the circuit must be linear. Superposition theorem is applicable only for linear network and superposition theorem is not applicable for non-linear network. Second, the circuit contains at least two energy sources. That means the circuit containing two or more than two energy sources, then we can apply the superposition theorem. Statement of superposition theorem. It states that in linear network containing more than one independent source and dependent source, the resultant current in any element is algebraic sum of the currents that would be produced by each independent source acting alone. All the other independent sources being represented meanwhile by their respective internal resistances. This is the statement of superposition theorem. While applying superposition theorem, we have to remember if the voltage source is there, then we have to short it, and if the current source is there, we have to open it. Now, steps to be followed in superposition theorem. Step number 1. Find the current through resistance when only one independent source is acting, replacing all other independent sources by respective internal resistances. Step number 2. Find current through resistance for each of the independent sources. Step number 3. Find the resultant current through the resistance by superposition theorem considering magnitude and direction of the current. Explanation of superposition theorem. For this, consider the network shown in figure. This network contains one voltage source and one current source, and here we have to find the current I4 flowing through resistor R4. Here we have to find the I4 flowing from this R4 resistance. Step number 1. Here we are applying only one voltage source at a time. Here voltage source V is applied and we have to find current flowing through this R4, that is I4 dash. Here the current source is there, so we open this current source, that is open circuit. Step number 2. Now we are applying second source, that means current source, and we have to find the current flowing through this R4 due to only current source, and the current flowing through this R4 denoted as a I4 double dash. Here the voltage source is there and this voltage source we short circuit. And in step number 3, we are finding the resultant current I4 through resistor R4 by superposition theorem, and we get total current or resultant current I4 is equal to I4 dash plus I4 double dash. Here we have to remember if the direction of this I4 dash and I4 double dash are same, then we have to add this current, and if the direction of this I4 dash and I4 double dash are opposite, then we have to subtract this I4 dash and I4 double dash. So these are the steps. Find the total current flowing through the element by using superposition theorem. Here some MCQs on superposition theorem. You have to find the correct answer and write the correct answer in comment box. First MCQ, the superposition theorem is not applicable to the network containing nonlinear elements, dependent voltage source, dependent current source and transformer. Second MCQ, superposition theorem requires many circuits to be solved as there are nodes, loops, sources, none of the above. Third MCQ, find the value of Vx due to the 16 volt source. Here we have to find the value of Vx, that means the voltage across 20 ohm resistor due to 16 volt source. Now for finding the voltage across 20 ohm, we have to open this 3 ampere and 15 ampere current source, and this 10 volt source we have to short, and from this we can find the voltage across resistor 20 ohm. Fourth MCQ, superposition theorem does not work for current